I'd like you to imagine that someone had cooked for us a really great meal, and as part of that, they had recipes and they had the correct ingredients in the right portions. Well, in DNS, there is a set of ingredients that go into making it work, and some of those ingredients involve different record types in DNS. For example, if Bob is here at computer 2 and has been configured to use this DNS server to resolve names to IP addresses, we already know that Bob makes a recursive request, and then this server goes out and either uses a forwarder or it walks the DNS tree with iterative requests to get that answer and feed it back to Bob. And if Bob is looking for an IPv4 address associated with the name of a server, what Bob is getting back is an A record, also known as a host record. And it's really simple. This record inside of DNS is the name of a server, such as dc-nug.nuglab.com, and then the associated IPv4 address. That is an A record. And if we're using IPv6 and we want to receive an IPv6 address, the type of record we're looking for is a quad A record. An IPv4 address is 32 bits long, and an IPv6 address is 128 bits. It's 4 times as long, and that's one way of remembering that a quad A record, 4 A's, is an IPv6 address, where an A record is simply an IPv4 address. So an example of a quad A record would be srv1.acme.com and the associated IPv6 address that is mapped to. Another record type is a CNAME, also known as a canonical name or an alias. An example would be we wanted customers to connect to ftp.nuglab.com to reach the FTP services there, but in the background, we're really hosting the FTP services on dc-nug.nuggetlab.com. And one of the questions that might come up is, okay, why exactly would we do that? And one of the answers would be we want to hide the actual implementation of where that FTP server is. For example, maybe today we have the FTP service running on dc-nug, and then tomorrow we want to run it on a completely different server. All we need to do is modify that alias, that CNAME record for ftp.nuglab.com to point to the different real server on the back end. So what happens in the background, if there's a resolution request for ftp.nuggetlab.com, the results coming back would be dc-nug.nuggetlab.com, at which point we would then look up the A record if we're looking for an IPv4 address for dc-nug.nuggetlab.com and get the IP address back of 192.168.1.100. Next is an NS, the name server record, which refers to an authoritative name server for a specific area or zone. So as an example, if we were looking for a name server that was responsible for nuggetlab.com, that domain, the response that we might get back is dc-nug.nuggetlab.com, at which point, to reach that server, we'd also have to resolve that to an IPv4 address by looking up the A record for that. And then once we have its IP address, we could make the request regarding a host at nuggetlab.com in hopes that that DNS server would respond as the authoritative server for that space and send the answer back to us. Now, when typical name resolution occurs, Bob makes a request, for example, like to go to www.google.com, and that's called a forward lookup, where the client is supplying a name asking for an IP address. However, there are times that we might have an IP address and we want to discover the name associated with that, and that's called a reverse lookup. And that's where we supply the IP address and we hopefully get the name as a result of that. Now, if that works, that's because someone has taken the time to set up what's called a pointer record, a PTR record, which maps an IP address to a fully qualified domain name. So in this example, if somebody did a request for a pointer record, a reverse lookup, and said, hey, I have an IP address of 192.168.1.100, can you tell me what name is behind that? If there was an entry for dc-nug.nuggetlab.com associated with that IP address, then the name server could respond back with that fully qualified domain name that's associated with the IP address. So that's an example of a reverse lookup. And here in parentheses, I'll just jot down PTR for pointer record. One of the most commonly used apps on the internet today is email. And as email gets forwarded between mail exchanges, an email server needs to be able to discover who, for example, is the appropriate email server or servers for a certain domain, like google.com. And to do so, we have a record for mail exchange servers called an MX. It's a mail exchange record. And an example of that is a record like smtp.nuggetlab.com as an email server that's responsible or can forward mail on behalf of nuggetlab.com. Now, if we do get the name, for example, of a mail exchange server, we still have to translate that to an IP address to use that server, at which point we go back and look for an A record associated with smtp.nuggetlab.com to get that IPv4 address so we can actually communicate with that server. Another type of record is the SRV, or service record. An example of how we could use or leverage an SRV or a service record would be this. Let's say we have 2 web servers in our domain. We could create SRV records that specify which exact hosts are running web services. And as part of the service record, it could identify the service, for example, HTTP. It could identify the protocol. For HTTP, that would be TCP. It could also identify the priority of the various servers, so that the client could then select the host with the best priority that's available. The service record could include wait, which is used as part of load balancing, as well as TTL, time to live, which indicates how long that information should be cached once it's retrieved. Another record type is text. Let's imagine that you and I are working in conjunction with another DNS server with its zones, and we're setting up some relationships between the two, including things like delegation, which we'll talk about when we talk more about zones. How does the provider over on their side of the fence verify that we have the proper authority over our zone before we set up an agreement? And one way of doing that is this. The provider could tell us, hey, we want you to create some text records with specific text. And then what they can do is they can query our DNS, verify that those text strings exist exactly as they requested. And then the provider could use that as a method just to confirm that we are in authority for our DNS zones and the records in our zones. And regarding zones, a zone is just a collection of records. In an Active Directory environment, that zone information can be stored as part of Active Directory. On a non-directory services environment, it can be kept in a file called a zone file. And every zone is going to have an SOA record as part of that zone, a start of authority record. And that's going to have information including who are the authoritative DNS servers for that zone, what are the time to live values, who's the owner and who's responsible for that zone, and much, much more. And we'll take a closer look at zones, including the different types, in a separate nugget on zones. And what I thought would be really fun for you and I right now is let's go to our lab environment and demonstrate how we can see with some command line tools all of these record types. So to start off, we're going to log on to our Windows 10 client machine as the domain administrator, and we'll supply our lab password. And then we'll click on the arrow to go ahead and log on as the domain administrator on this Windows 10 machine. So just to verify where we are, we're on the client-nug machine, which is Windows 10. And currently this client is configured to use the Windows 2016 server as its DNS server. And what we're going to do is we're going to open up the integrated scripting environment by clicking on this icon right here on our Windows 10 client. So in the first tab, we're connected directly to this Windows 10 machine. I also opened up a second tab to DCNug. And to do that, we simply go to File, and from the drop-down, New Remote PowerShell tab. And then you can put in the name for DCNug as we've done in previous nuggets to open a separate tab there as well. I've also, for the interest of time, got a few commands in each of the windows. So on the DCNug server, I've got one command, clear-DNS server cache, in case we need to use it. And then on our initial tab here, for the local machine, to save a little bit of time, so it's not just a typing exercise for me as we go through this together, I've got the first 9 lines here using NSLOOKUP. Now, NSLOOKUP can be used with all the parameters as shown here, or it can also be used in interactive mode inside of a command line window. And then the last 3 commands are actually PowerShell commands that we can use for name resolution as well. So before we launch these, let's go back to our DCNug tab just for a moment. So my cursor at the moment is right here. So with my cursor on that row, we can either click on Run Selected or press F8, and that will run it for us. Also right here, we have the squeegee that can clear off the output down here just to make it a little bit easier to read. So with my mouse right at the end of line number 1, I'm going to go ahead and press F8 to go ahead and launch that, and click on Yes to confirm the server cache deletion. And then we'll go back to tab number 1, which is on our local Windows 10 client. And let's go ahead and actually do one more thing here. I'm going to add one more line, and that is clear DNS client cache on the local machine before we start as well. And I'll press F8 to execute that. Great. Then I'll use a squeegee to clean it up, and let's run line number 2. NSLOOKUP www.google.com, and this will give us a bunch of records back. So with row 2 highlighted, we'll press F8. So there's the command that was executed. Right here it's showing us the address of our DNS server, which is our domain controller / DNS server at 192.168.1.100. And the reason it shows up as unknown is that it tried to do a reverse lookup to get a pointer record to find out the name behind that IP address of our DNS server. And because we don't yet have reverse lookup set up, and there aren't any pointer records yet in our DNS server, that's why it's showing up as unknown right here. And then regarding www.google.com, we have an A record, the one here that starts with 216, and we also have a quad A record, which is an IPv6 address. So here's an A record, and here's a quad A record. So from our table of common DNS resource record types, we now have an example of two of them, an A and a quad A record. Next, I'm going to hit the squeegee to clean that up, and let's go ahead and look for a specific type of record. And to do that, we're going to go to row number 3. So clearing the output again, if we want to see just A records, for example, from Microsoft.com, we can go to line 3, highlight that, hit F8 to run it, and that's showing us an A record right there. It's also giving us some aliases, which represent CNAME records. It also indicated that we received this information from a non-authoritative server, so it's very likely it was cached somewhere and fed to us from some other resource other than the authoritative name server for Microsoft.com, which is okay. Next, let's go ahead and squeegee off the bottom portion, and let's go to row number 4. We'll do an NS lookup looking for just quad A records, and this time we'll use the host www.cisco.com as the example. So with row number 4 highlighted, we'll press F8 to execute that. And that timed out. That did not work. So it basically timed out. Let's try it again. So I'm going to go ahead and use the squeegee and press F8 once again. There we go. So now it's indicating we got a non-authoritative answer because we didn't get it from the horse's mouth, but we did get the information, and here are 2 IPv6 addresses, 2 quad A records, and we also have some CNAME records down here. Next, if we wanted to make a request and take a look at just name server records, let's go ahead and clear off the bottom portion with the squeegee. We'll highlight row number 5 and do an NS lookup, specifying the type of record we're looking for is an NS, a name server record, and we'll specify the domain of cbtnuggets.com, and we'll press F8. And based on this output, we've got 4 name servers that are able to serve up the names for cbtnuggets.com, and based on who they are, looks like Amazon Web Services is handling that for us. Fantastic. So out of those 4 name servers, we also resolved one of them, the NS315, to an A record. So these 4 right here are name server records, and this one IPv4 address is an example of an A record. That again maps to that specific host name right there. Next, if we wanted to look at a pointer record, we'll go ahead and squeegee off the bottom portion. We'll highlight row number 6 and do an NS lookup -type equals PTR. And the pointer record, once again, is used with reverse lookups where we have the IP address and we want to find out a name associated with that IP address. So with row 6 highlighted, we'll press F8 to launch it. So based on results, this IP address has these names associated with them. So these are examples of pointer records that somebody has created associated with 216.58.28.100. And when we go to zone creation and we create our own reverse lookup zones, I also want to just give you a little heads up that when we create the reverse lookup zones, we put in the IP addresses back-asswards. We put in each of the octets of the IP address in reverse order. So for 216.58.218.100, it goes in as 100, the last octet, then 218, then 58, then 216. And we'll have some hands-on practice with that when we create reverse lookup zones in a later nugget. Next, if we wanted to look for mail exchange records, we can go to row number 7. We'll clear the output with the squeegee, and we'll hit F8 to run that. Looking for MX records for Google.com. So that returns a list of the MX records for Google.com. So here are the names. And then we also have some A and quad A records. So these are MX up here. And then we have A and quad A records regarding those email servers. If we want to do an NS lookup and retrieve service records, we can use line 8 as an example. So I'll go ahead and squeegee off the bottom portion to keep it nice and clean, and we'll execute row number 8 by highlighting it and pressing F8. So this service record right here got added as part of DNS when we added Active Directory to our DC-nug server. And that's because this server is a domain controller. And in this example, it has the name and IP address of a server, the only domain controller that we have so far, that's providing domain controller services. It's got port 389, which is used for a whole laundry list of things in Active Directory, including user and computer authentication, replication, group policy, trusts, and more. It's got a priority field of 0. In priority, the lower number is more preferred. And it's got a weight of 100. So we'll clear that bottom portion off with the squeegee once more, and let's take a look at a start of authority record. In this example, we'll use Amazon.com, and we'll highlight that, which is row number 9, and press F8. So here's our command. And every zone is going to have an SOA, a start of authority record, at the beginning of that zone. Here it's showing the primary DNS server that's authoritative for the zone. Here it's showing the email address of the administrator responsible for the zone. So the email here would be root@amazon.com. The period before the domain would be swapped out for an @ symbol for a valid email address. It has a serial number, which indicates how many times that this DNS zone has been updated, which is quite a few. It has a refresh value, which implies to a secondary server how often it should check to see whether the zone has been changed. There's a retry interval, and that retry specifies to a server that's a secondary DNS server for that same zone. If it requested a zone transfer and it failed, the retry specifies how long it should wait before it tries again for another zone transfer. The expire field is also for the benefit of a server that has a secondary copy of that zone. And in this example, it's 35 days. So after 35 days, if there hasn't been an updated zone transfer, the secondary server is going to consider his information invalid, no longer good. And the default TTL here is 1 minute or 60 seconds. So if a record is retrieved, if it doesn't specifically in that record itself have a TTL, this default TTL will kick in, and somebody who caches that information is going to think, okay, this record is valid in my cache for 1 minute. And then after that time, it can go ahead and discard it. And then if the time to live expires and it needs that information again, it's not going to get it from the cache. It'll have to go make a query again. This is also showing us right here the IPv4 address associated with this fully qualified domain name. And that means that this part right here is a representation based on an A record. So up here we have the SOA, the start of authority record, and then down below here the resolution of the actual host to an IP address is an example of an A record. So let's go ahead and squeegee off the bottom portion of that and highlight row number 10 and do an NS lookup looking for a specific TXT record. And we'll use Microsoft.com as an example. With that highlighted, we'll press F8 to continue. So for example, if we were integrating our DNS as part of SharePoint, Online, or Office 365, and Microsoft needed to verify that we are indeed responsible and have control over a certain domain, they could ask us to create a text record, they could query that, and if the text record is there and it matches what they asked us to put there, then they would have some confirmation that yes, we do have management capability on the DNS zone that we're now going to cooperate with Microsoft on. And then if we scroll down a little bit more, I've got some commandlets from PowerShell that we can use as well. So we'll use the squeegee to clear off the bottom portion, and let's go ahead and highlight row 11 and do an F8 for resolve-DNS name cisco.com. So in the output here, we have a quad A record, an A record for IPv6 and IPv4 respectively. We have a name server record that refers to the name server at ns1.cisco.com for resolving names at cisco.com. And again, to get the actual IP address behind ns1.cisco.com, we do a request for an A record if we didn't already have it cached that resolves to ns1.cisco.com, so we could make queries. And as we scroll down the list, there's multiple name servers that have been provided. And here are some A records and quad A records for the IPv4 and IPv6 addresses respectively for those name servers. And we do the same thing, for example, for Amazon. So with row 12 highlighted, we use a squeegee and then press F8. And then row 13, if we wanted to resolve a specific host like www.amazon.com, we'll go ahead and squeegee off the bottom. With row 13 highlighted, we'll press F8 once again. So for that host, it resolves to a couple of different CNAMEs, canonical names, aliases. And then in the output it shows that for this host right here, opf-www.amazon.com, here is the specific IPv4 address for it, which represents an A record. And associated with that A record, we have the time to live of 55, which could be individually associated with that record, or it could be a default from the DNS server. In this nugget, we've both discussed and demonstrated several of the DNS record types that we're commonly going to find in the world of DNS. And now, my friend, it is your turn. I'd like you to launch the labs and practice each of the commands that we've done together in this nugget to help reinforce the commands and the output. So have some fun and practice in the labs. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.